Right now, somewhere in southern Spain, the asphalt is hot enough to warp a shoe sole. Right now, in parts of Romania and Ukraine, wildfire smoke is drifting over wheat fields that haven't seen real rain in weeks. And right now, thousands of kilometers away in the middle of the Pacific Ocean, a body of ocean water the size of a continent is heating up so fast that meteorologists are running out of comfortable ways to describe it. These two things sound unrelated. They are not. What is happening in the Pacific right now is about to reach across the entire planet and flip the switch on European weather, and the transition has already started. We are going to break this down piece by piece. What is actually happening with the heat gripping Europe right now, what scientists just confirmed is developing in the middle of the Pacific Ocean, why a cold patch of water sitting in the North Atlantic matters more than almost anyone realizes, and what all of this is pointing toward for autumn and winter across the continent. No exaggeration, no fear-mongering, just what the data is actually showing and why it matters to you if you live anywhere in Europe. Before we get into it, drop a comment and tell me where you are watching this from. Are you currently baking under one of these heat domes, or has your part of Europe already started to cool off? I read every single comment, and I want to know what it actually feels like on the ground where you are right now. And if you want to keep tracking this pattern shift as it develops week by week, subscribe to the channel. It is free, it takes 2 seconds, and it means you will not miss the next update when the system starts to turn. Let's get into it. Let's start with what is happening above your head this week, because this is the story everyone in Europe is already living through. For most of July, and now into August 2026, a massive area of high pressure has been sitting almost motionless over the continent. Meteorologists call this pattern an omega block, named because on a weather map, the shape of the jet stream curls into something that looks like the Greek letter omega. A dome of high pressure sits locked in the middle, with low pressure systems parked on either side, one out in the North Atlantic, one over toward Russia. Because the whole structure barely moves, the heat underneath it does not move either. It just keeps building, day after day, like an oven with the door shut. This is the fourth major heat wave of the summer to hit Europe, and forecasters have been describing the upper-level temperature anomalies driving it as pushing into the top 1% of what has ever been recorded for this time of year. The core of the heat has been sitting over Iberia, France, Italy, the Balkans, and southeastern Europe, with nighttime temperatures in cities like Naples, Barcelona, Rome, Valencia, Nice, Thessaloniki, and Athens, struggling to drop below 20 degrees Celsius even after midnight. That matters more than people realize, because the body needs cooler nighttime temperatures to recover from daytime heat stress. When nights stay hot, heat-related health emergencies climb sharply, especially for older residents and people without air conditioning, which is still a huge portion of the population across southern and central Europe. Meanwhile, the drought underneath this heat dome has been getting worse in real time. Large parts of England, Wales, and Ireland went over 40 consecutive days without measurable rainfall in some locations, an extraordinary stretch for a region that is usually one of the wettest corners of the continent. Soil moisture has been draining out from underneath crops across huge stretches of Central and Eastern Europe, and in Ukraine, Romania, Moldova, and the Balkans. That combination of extreme heat, bone-dry ground, and gusty winds has been fueling fast-moving wildfires and severe thunderstorm outbreaks. And here is the twist that catches a lot of people off guard. The same atmosphere that is baking one region can be dumping intense flash flooding on another region just days later, because when a heat dome finally starts to buckle, the atmosphere does not calm down gently. It often swings hard in the opposite direction first. Scientists have been blunt about why this keeps happening. A study published a couple of years ago found that the type of atmospheric blocking pattern responsible for heat domes and stalled flooding events has nearly tripled in frequency since the 1950s, and that trend is directly tied to human-driven climate change. This is not a one-off freak summer. It is part of a pattern that is becoming more common, more intense, and more stubborn to shift. But here is the part almost nobody outside of meteorology circles is talking about yet. The heat dome sitting over Europe right now, as brutal as it feels, is not actually the main event. It is the opening act. Because thousands of kilometers away in the tropical Pacific Ocean, something much bigger has been building since early summer, and it is about to reshape the entire global weather pattern heading into autumn and winter. Let's talk about what is actually happening in the Pacific, because this is the part that determines what comes next for Europe. Since July, ocean temperatures across the central and eastern tropical Pacific have been rising fast, and they have been rising in a very specific, very recognizable way. This is what is known as El Niño, a natural cycle where the surface waters of the equatorial Pacific swing between warmer and cooler phases every few years. We are currently watching one of the strongest El Niño events develop in years, with forecasters now describing the trajectory as pushing toward what some are calling a super El Niño. a term reserved for only the most powerful events on record. Why does warm water sitting near the equator on the other side of the planet matter to someone standing in Berlin or Warsaw or Madrid? Because the atmosphere does not respect oceans, coastlines, or continents. When that much warm water builds up in the tropical Pacific, it fundamentally changes where air rises and where it sinks across the entire planet. Meteorologists track this using something called the Walker circulation, essentially a massive east-west loop of rising and sinking air that girdles the tropics. During a strong El Niño, that loop gets scrambled. Rising air shifts toward the central and eastern Pacific instead of its usual position further west, and sinking air builds up strongly over places like the Indian Ocean. That shift sends ripple effects through the jet stream, the fast-moving river of air 30,000 feet above our heads that steers nearly every major weather system in the northern hemisphere. Once the jet stream gets pushed and pulled by a strong El Niño, the impacts show up far outside the tropics. Storm tracks shift. Pressure patterns that would normally sit in one place get relocated. And by the time all of that filters through the atmosphere and reaches Europe, it can mean the difference between a mild, wet winter and a winter dominated by blocking high pressure that locks in either unusual cold or unusual warmth for weeks at a time. This is not speculation. This is how El Niño has behaved in past strong events, and it is exactly the mechanism forecasters are watching develop right now heading into the back half of 2026. Now here is where it gets more complicated and more interesting, because El Niño is not acting alone this time. There is a second signal developing at the same time, sitting much closer to Europe, and it could either reinforce what El Niño is doing or complicate it significantly. In the far North Atlantic, in the same stretch of ocean where large-scale cooling anomalies have shown up before, a patch of unusually cold water has been expanding again. Meteorologists sometimes call this the cold blob, and it sits in a region that is anything but isolated from the rest of the atmosphere. The North Atlantic is one of the most influential patches of ocean on the planet when it comes to steering European weather, because it sits directly upstream of the continent, feeding air masses and storm systems that roll straight into Western Europe. When that patch of ocean runs colder than normal, it can alter the temperature contrast between the Atlantic and the surrounding air, which in turn can shift where storm systems track and how strong the pressure gradients become as those systems approach the European coastline. Past instances of an expanding cold anomaly in this exact region have preceded, and in some cases lined up directly with, significant pressure and jet stream disruptions during the following winter. Combine a strengthening super El Niño out in the Pacific with an expanding cold anomaly in the North Atlantic, and you have two major global drivers pointing at the same stretch of time, both capable of reshaping the atmosphere over Europe, and both currently active at once. And there is a third piece to this puzzle, one that plays out not at the ocean's surface, but far above our heads, in a layer of the atmosphere most people never think about. Roughly 30 kilometers up in the stratosphere sits a massive rotating pool of frigid air that circles the North Pole every winter. This is the polar vortex, and how tightly or loosely it holds together has an outsized influence on whether cold air stays locked up near the Arctic or spills southward into the mid-latitudes, including Europe. Forecasters have already detected the early stages of a stratospheric wind shift this year, a reversal pattern that, combined with a strong El Niño, has historically been associated with a weaker, more easily disrupted polar vortex later in the winter season. When the polar vortex stays strong and tightly wound, cold air generally stays bottled up near the pole, and Europe tends to get milder, more Atlantic-driven winters with a steady parade of storms rolling in off the ocean. But when the polar vortex weakens or gets knocked off balance, which is sometimes called a sudden stratospheric warming event when it happens abruptly, the cold air that was contained near the pole can break loose and plunge south. This is the exact mechanism behind some of the most memorable cold snaps Europe has experienced in recent winters. Sharp, sudden intrusions of Arctic air that catch entire countries off guard because the weeks before looked completely mild. There is a fourth ingredient in this mix, and it comes from even further north than the cold Atlantic blob. Arctic sea ice hit a record low for mid-June this year, an extraordinary milestone that reflects just how much extra heat has been absorbed by the polar region over the past several months. Thin, fragile sea ice means more open ocean water exposed to the atmosphere, and more open water means more heat and moisture getting released into the air above the Arctic. That extra warmth pumped into the polar atmosphere is one of the factors that can help destabilize the polar vortex, adding yet another push toward the kind of disrupted winter pattern scientists are now watching build. So when you put all four of these signals together, the heat dome baking Europe right now, a rapidly strengthening super El Niño in the Pacific, an expanding cold anomaly in the North Atlantic, and a record low heat absorbing Arctic sea ice extent feeding into early stratospheric wind shifts, you get a genuinely unusual and highly watched setup heading into the second half of 2026. Multiple major global weather drivers, each capable of reshaping the atmosphere on their own, are now active and interacting at the same time. That is exactly why meteorologists across Europe and North America have been publishing update after update on this pattern over the past several weeks. This is not a normal, quiet transition from summer into autumn. Something bigger is loading up in the background. Now let's talk about what this actually means for the coming months, because I want to be completely honest with you about both what we know and what we don't know yet. Long-range seasonal forecasting is not the same as predicting tomorrow's weather. Nobody, no agency, no model, can tell you today exactly what temperature it will be in Lyon or Krakow on the 15th of December. What forecasters can do is look at the strength and behavior of these global drivers, compare them to how similar setups played out in past years, and build a probability picture of what is more or less likely. Here is that picture as it stands right now. As the current heat dome finally breaks down over the coming weeks, expect the pattern across Europe to become considerably more unsettled through the transition into autumn. The heat, currently centered over the Mediterranean and southeastern Europe, is expected to gradually shift and weaken, but not before squeezing out one more round of intense conditions, especially further east, into places like Poland, Germany, and Western Russia, before Atlantic systems begin to reassert themselves. That transition period is when the flash flooding risk tends to spike, because a heavily dried out landscape suddenly getting hit by concentrated bursts of rain cannot absorb the water fast enough, leading to rapid runoff and dangerous flash floods, even from what might otherwise be a fairly ordinary rain event. Moving into the heart of autumn, the influence of the strengthening Super El Niño is expected to become more pronounced. Historically, strong El Niño events tend to push the North Atlantic storm track and jet stream into configurations that can bring more active, wetter conditions to parts of Western Europe, while other regions see the opposite effect, depending on exactly how the pressure patterns align. The uncertainty is real, and forecasters are upfront about it. Agreement across major forecast models like ECMWF, the WMO's multi-model outlook, and NOAA's CPC assessments is much stronger on the temperature signal than it is on the precise rainfall pattern, which is a normal limitation of this kind of long-range outlook. Where this gets most interesting and honestly most consequential for anyone in Europe who cares about winter weather is in the December through February window. If the polar vortex does weaken or fracture the way the current stratospheric signals suggest, it might. The risk of a sudden sharp cold air outbreak reaching deep into Europe goes up substantially compared to a normal winter. This does not mean every week of winter turns brutally cold. It means the odds shift toward at least one and possibly more. Then one significant cold intrusion event, the kind where a mild pattern can flip within days into a period of hard frost, snow, and disrupted travel across large parts of the continent, catching people off guard if they are not paying attention to the signals building right now. At the same time, remember that cold blob sitting in the North Atlantic. If that anomaly holds through the winter months, it adds another layer of complexity because it can interact with the storm track in ways that either reinforce a blocked cold pattern or, in some scenarios, help kick a stronger storm track further south, bringing more active, wetter, and windier conditions to parts of Western and Southern Europe instead. This is genuinely one of the more complex seasonal setups meteorologists have tracked in recent years, precisely because you have a strong tropical Pacific signal, a strong North Atlantic Ocean signal, and an early polar stratospheric signal all developing in the same window, and they do not all push the atmosphere in exactly the same direction. What forecasters are confident about is this: the quiet, stagnant, locked-in heat pattern currently sitting over Europe is not going to be the story for much longer. The atmosphere is already loading up the ingredients for a much more dynamic, more volatile pattern, heading into the back half of the year, one shaped by a rare combination of a powerful El Niño, an unusual North Atlantic Ocean anomaly, and early signs of a wobbly polar vortex. Whether that translates into a historically cold winter, a wild swing between mild and brutal conditions, or a wetter and stormier season depends on exactly how these signals continue to evolve over the coming weeks. And that is exactly why meteorologists are watching this so closely right now instead of waiting until November to start paying attention. So, what should you actually take away from all of this if you live in Europe? First, do not assume the current heat and drought conditions are simply going to fade quietly into a calm autumn. The transition out of this heat dome carries real flash flood risk in areas that have gone weeks without meaningful rain. So if you are in one of the regions that has been under drought stress, pay attention to short-term forecasts once the pattern starts to break, because the ground genuinely cannot absorb heavy rain the way it normally would. Second, keep an eye on how this Super El Niño and the polar vortex signals continue developing through September and October. These long-range signals tend to sharpen and become more reliable as we get closer to the actual season, so an early update in September could look meaningfully different from where things stand today. And that is not a failure of forecasting. That is simply how atmospheric prediction improves as the event gets closer. Third, if the pattern does trend toward a disrupted polar vortex, and a sudden cold air outbreak becomes more likely later this winter. That is exactly the kind of event that benefits from advance warning, because European cold snaps tied to polar vortex disruptions can develop and intensify faster than people expect once they get moving. This is also a good moment to remind you why these long-range global drivers matter beyond just knowing whether to pack a heavier coat. Strong El Niño events and disrupted polar vortex winters have historically been associated with increased strain on energy grids during sudden cold snaps, transportation disruptions when snow and ice arrive with less warning than usual, and agricultural impacts from both the current drought stress and any later season cold snaps that catch crops at a vulnerable stage. Understanding that a bigger pattern shift is already loading up in the background gives individuals, farmers, and infrastructure planners real lead time to prepare, rather than reacting after the fact. Here's the honest bottom line. Europe is currently living through the peak of a stubborn, record-challenging heat pattern, but that pattern is running on borrowed time. Underneath it, in the Pacific, in the North Atlantic, and in the stratosphere above the Arctic, the ingredients for a genuinely significant shift in the continent's weather are already assembling. A rapidly strengthening Super El Niño, an expanding cold anomaly in the North Atlantic sitting directly upstream of Europe. Record low Arctic sea ice pumping extra heat into the polar atmosphere, and early signs of a stratospheric wind reversal that has, in past years, gone hand in hand with a wobblier, more easily disrupted polar vortex. Individually, any one of these would be worth watching. Together, all four active at the same time is what has meteorologists across the continent describing this as one of the more consequential seasonal transitions in recent memory. We do not know yet exactly how this resolves. Nobody honest in this field will tell you they do. But we do know the quiet, locked-in weather pattern currently baking Europe is not going to be the story much longer. And we know the pieces now in motion across the Pacific, the Atlantic, and the Arctic have a real track record of reshaping European winters when they line up this way. That is worth paying attention to, and it is exactly why we are going to keep tracking every update on this pattern as it develops, week by week, straight through autumn and into winter. If this kind of breakdown is useful to you, subscribe so you do not miss the next update when new model data comes in, because this picture is going to keep sharpening over the next several weeks. And drop a comment, letting me know what the weather has actually been like where you are right now, because I want to hear it directly from people living through this heat before we track what comes next. Stay ready, stay informed, and I will see you in the next one.